All right, we're going to be talking about perpendicular and angle bisectors. This is section 5.1, new chapter. The title here, this perpendicular and this angle goes both with bisectors because we're going to do perpendicular bisectors and angle bisectors. So we have one noun and two adjectives, and we have a perpendicular bisector and an angle bisector both. Okay, bringing a little English into math. All right, we have some new theorems. We're going to talk about them on your postulate sheet there. It's the first one and the third one. We're going to read them. I guess we'll just start this side and work our way around. We're going to be talking about them. So we'll just do with you. If you'll do the first one, Amy.
Okay, perpendicular bisector theorem. If a point is on the perpendicular bisector of a segment, then it is equidistant from the endpoints of the segment.
Good job. All right, can you read the third one, Brett?
Angle bisector theorem?
Yes.
Yes.
If a point is on the bisector of an angle, then it is equidistant from the two sides of the angle.
Very good. I want you to notice that underneath each of those, there's a converse. You're going to write those converses for homework. And actually, there's
only
a blank.
One converse
There's
is
only
a
one
blank.
converse.
Yeah, that's what I'm just about to talk about. There's one that's blank. It's the converse to the perpendicular bisector theorem. But number 4, I have started off. But it's not complete because it is the converse, but they had to put a little qualifier at the beginning. And so, what's a perpendicular bisector?
Something that's perpendicular to the other line and cuts it in half.
Something that's perpendicular and cuts it in half. Okay, so if I have a line and a perpendicular line would have to come straight down, right? Probably, you can't see it yet. Half decent. So that would mean that this would have to be equal to each other, correct? And it would also have to be perpendicular also. So that would be a perpendicular bisector, something that cuts it in half and is perpendicular. Okay. What does the word equidistant mean?
Equal distance.
Equal distance. It's all one word. It's two words put into one. It's an equal distance. So the picture I had a moment ago, right here, this point right here is equidistant from the end point down here and this one down here. The cool thing about it, which you guys just told me, is that any point on this perpendicular bisector is equidistant from the endpoints. I just drew 3 triangles. What kind of triangles did I just draw based on that you just learned that those points were equidistant from the endpoints? So because this is congruent to this one is congruent to this one, and 1, 2, 3, 4. 1, 2, 3, 4. I just drew 3 isosceles triangles. So
The top one looks almost like it could be equilateral then.
The top one, then it could be, and technically an equilateral triangle is isosceles, okay? So I'm going to challenge you to give yourself a picture. I'm going to take off some of this stuff. I'm only going to do that one. I'm going to challenge you to, and I'm going to erase these. Oh, I can't do that. I'm going to have, for your numbers 1 and 2, on your terms page, this is a picture that you can draw. If you'll give yourself a line here, like I have the black bottom one, you'll have a perpendicular bisector. Make sure you mark it as such. Any point on that perpendicular bisector will be equidistant from the sides. That way, when you put it inside of your postulate book, you'll have a picture to refer to. And like I've said many times before, a picture is way easier to find than all those words. You can even give yourself some marks on here that those are the equidistant part. If you want to put any labels on there based on that, you can. This will go for a picture for numbers 1 and 2 on there. Now, I'm going to review something that we did last week. Last week, I gave you an isosceles triangle, right? We folded it in half, and then I actually made that a little darker so you could see it. This is what you just drew. So last time when we met together, you had a little advertisement that we were going to go further with this. This is an isosceles triangle. This thing we drew right here is the perpendicular bisector because when we folded it, we noticed that this side went right on top of that side, and so it was equal. When we fold it like that, this fold is going to be a 90-degree angle. When we did that, we noticed that this side over here laid right on top of that, so that this point at the top was equidistant from the endpoints down here. All right. We also created two triangles. What do we know about those two triangles? They're congruent. I've got a 90-degree angle right here. We just said that those yellows were congruent, and we said that these were congruent. Why are these two triangles congruent? We had side, 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 angle, side, angle, side, angle, side, angle, angle, side, and hypotenuse leg.
Oh, no.
There's multiple ways to do that.
But what are we trying to do?
We're trying to tell me why are those two
Side,
triangles.
side.
I heard side, side, side. I agree with that because we can do that.
Yeah.
All right, side, side, side. I'm going to take that out. Based on what I've
Side,
just
angle,
written right
side.
here,
Oh, wait.
No, wouldn't be side angles.
No.
if we had
Doesn't
those, we
matter.
could be side, ankle, side. But
But
Yeah.
technically they are.
technically they are.
Because
Why?
they lay on top of each other.
And what kind of triangle was that? Isosceles. And what do we know about the base angles of isosceles triangles? They're congruent. So yes, Amy, it could be side, angle, side. We had side, side, side. Okay, without those two that we just did there, without those there, let me put my side back. What kind of triangle do we have here?
A right triangle.
A right triangle.
Oh, that's what I was referring to.
HL. There we go. Yes, HL.
Oh, yeah, that's...
Yeah.
Okay.
And I guess if you want to do it, we had that with those. So instead of, if we took this out here, we'd have, ooh, that's not angle, angle. It's side, side angle. That's not one. So I guess we wouldn't have that. I'm trying to see.
It's side-
Technically, this does bisect right there.
But Mama, technically, if you have that other angle over there, you could do angle, angle, side. With if you take out the center one.
Oh, these ones here. Yeah,
Yeah.
we do. Because they're two right angles. Yeah, we do have angle, angle, side. Yes.
Oh, that's what I was referring to. I was
That's what you were
saying
referring to.
side
My
angle,
bad.
yeah.
My bad. I'm sorry, Amy. Yes. All right. So we have. So you needed to have all that stuff about your triangles, so we can now go to this base angle thing also. To go to the base angles, and to now go to the one we just talked about just a moment. The one you just learned about. If it lies on the perpendicular bisector of a segment, then it's equidistant from the side. Has everything to do with it. It's an isosceles triangle. All right. I have a diagram up here, and I'm telling you that MN, which is this line, I should have put a little line signifier up there above it. I should have come up here and did this. Line MN is the perpendicular bisector of ST. What unmarked segment lengths in the diagram are equal? I want you to, somewhere on some piece of paper, I want you to write that down. Don't say it out loud. I want you to write some unmarked, what are some unmarked segment lengths that in the diagram that are equal? Based on some of the new theorems that you just learned.
I thought SM and TM would be congruent.
You think
but
SM
I don't really...
SM is, I shouldn't make that M capital. And you said TM?
Yeah.
Who agrees with her?
I don't really know why, but I just...
Anybody agree?
Wait.
What would be your reason, Amy? Is anything on that perpendicular bisector? Which point's on the perpendicular bisector, Amy? I agree with you, by the way.
Yeah. Wait.
I do agree with you.
Which point on the perpendicular? It would be the...
Yeah, 'cause it says that MN is the perpendicular bisector. This right here is the
Oh, so
perpendicular.
that would be considered... Okay. I had a feeling it would be considered MN.
So there's a point that's on that perpendicular bisector, correct? What's the point that is in common with these two over here? What's
M.
M? M's on the perpendicular bisector, correct? Okay, so if M's on the perpendicular bisector, it's equidistant from what? from T and S, isn't it? So that means these are equal. Okay? So that would mean that SM is equal to TM. All right? Now, the next question I have for you, and we just talked about it. Oh, no. If I extend it out, this question, why is Q on MN? If I extend this line out, not just because it looks like it in the picture, because it could just go right under or something. If I extend it out based on a theorem, will this line go through Q?
Yeah, the converse of the perpendicular bisector.
The converse says what? Right.
That if it's equidistant for the endpoints of the segment, then it is a perpendicular. And since both sides are congruent.
These sides are congruent right here.
Technically the angle bisector though, not converse of the angle bisector, not converse of the bisector. Because it's going through Q.
It's going through Q, but it's because it's equidistant.
Oh, okay.
All right, so that is that's the perpendicular bisector of this side, and so Q will be on the perpendicular bisector. Okay, all right. And I did those in different colors to signify that instead of doing extra lines, one's black, the two black ones go together, and the two red ones go together. All right, questions? All right, now we're going to talk about angle bisectors. D is on the bisector of angle BAC. I'm going to tell you right now that DB is perpendicular to AB, and AC is perpendicular to BC and AC. Now, first of all, what's the theorem say about angle bisectors? That's number 3. Angle bisectors. Can someone tell me what that says again? Brett, you read it to me. Can you read it again?
If a point is on the bisector of an angle, then it is equidistant from the two angles of the angle.
Okay. D is on the angle bisector. So it is equidistant from those sides. And the question would come, equidistant, which one of these is equidistant? I mean, how do I know where to draw that equidistant from?
The
Point?
It has to be the shortest distance, okay? The shortest distance between this and here is a perpendicular. If you need to put something down in there that it's going to be a perpendicular, when that distance is going to be a perpendicular, that means that these distances are equal. This is a picture that you can draw for numbers 3 and 4, stating somehow you might want to put a line from yours to the word perpendicular bisector, but here's a picture. I've got some squinching of some foreheads because they're getting some questions, I think. So after you've drawn that, ask me some questions. Some questions that go along with this. Name 2 congruent angles and why they're congruent.
BAD and DAC.
Say the first one.
DAD.
DAB. Okay, I'm going to put that one right there. And what does that one go with?
CAD. Or actually DAC if you want to be correct about it.
what?
CAD?
DAC.
DAC.
Oh, yeah.
I don't know why I did that. Need to put an angle in there. Ugh.
Why is there a dot?
I don't know why there's a dot. I was wondering that same exact thing. DAC. Is that what you said?
Yes.
All right. Why are those 2 congruent?
Because the bisector, so it puts it.
Because if we want to state a reason, like on a postulate book, the definition, angle bisector. Okay. So what else are congruent? BDA.
Mm-hmm.
So I'm gonna mark them with a different color. You're saying this one right here and this one right here, correct?
Oh, yeah.
Why would you think so?
Well, it's sort of like the same thing, just reversed. Like, if you were...
Do we know anything of a
Yeah,
Okay.
the 2 sides they're equidistant.
They're equidistant.
in its definition of bisector.
Oh, but do we know, did it say up there that it bisects angle BDC?
No, but it cuts it in half, so
How do we know it cuts it in half?
because the two sides are equidistant.
That equidistant part goes with this.
I know. It's cutting the angle BDC in half, so it's an angle bisector of BDC.
You're not told that. You're told that it's the bisector of A should be AC. I know up there in my given. What else do you know up there in your given?
TB is
Perpendicular.
AP,
And those are perpendicular, correct?
and PC is
Are those equal?
Yes.
Yes. All right. So we can go A, BD, right? And A, CD. Now, Heidi, now you could say that those other ones were equal.
Why?
Why?
Why couldn't we have done it the other way before? Because technically,
From the given, we can now state those if we needed a reason. This is the third angle theorem. I don't know if you remember it. If two angles of one triangle are congruent to two angles of another, then the thirds are. But we couldn't jump to that right away. We needed to have these first. Do we have any triangles that are congruent in here?
yeah,
Why?
they are.
Is there such thing called angle, angle, angle?
No, but they're side, side, side.
Is there a side, side, side?
Yes.
All right, how do we get side, side, side? I've got a side here, and we have there. Do we have that third one yet?
No, we know by like.
We can do it by
We can
CPC to
just
C.
use it.
So how do we know the triangles originally?
Angle, side, angle.
Angle, side, angle. Yes, twice.
Yeah.
Angle, side, angle, or angle, or side, angle, side.
That's
Okay.
what I was thinking
Say that again.
of. I was doing side angle.
You were doing the side, angle, side. Yeah. All right. Now we've answered a couple questions with that one. All right. We got two congruent segments. We just did the two congruent segments. We got the here and here. And we have CPCTC eventually here too. All right. Looks like that thing was growing hair for a moment there. So many things. We got congruent triangles. Okay, this is what I need you to do is get your assignment out. We're going to do some problems. This is where the rubber meets the road, where you really figure out how in the world you can do this. Numbers, we're going to do the odds, 1, 3, 5, 7. All right, number 1 says each figure, the instructions for everything says each figure shows the triangle with one of its angle bisectors. The measure of, we want you to find the measure of angle 1 if angle XVW is 46 degrees. If the whole thing's 46, how much is that one? Angle bisector means it cuts it in what? Half. So if you know the whole thing's 46, how do you find that piece?
23?
How much?
23.
23. Just divide it in half. 46 divided by 2. So 23. Number 3, unless there's any questions on number 1. It says, now we're going to use do this with some algebra. It says measure of angle 2 is 13x minus 2. And measure of angle 1 is 12x. How do I make an equation for that? 13x minus 2.
Add them together and then
Oh,
divide
wait.
them by 0.
Yeah. No.
Not by 0.
I mean by 2.
You could, but we need we need an equation. What do you know if it cuts it in half? What do you know about each piece?
They're congruent.
They're congruent. So I could make 13x minus 2 equal to 12x. I'm going to move the 12x over there and move the 2 over there. When I move the 12x to the other side, I'll have how much? What will I have left? X equal, I'll have x on that side, right? Amy asked me a question. You look like you're confused.
Wait, did you just switch like the 2 to the other side and the 12?
Yes. I'm going to just move the 12x over there by subtracting.
Wait,
And then-
can you do it that way? Because I thought you had to subtract the 13 from 12 because there was nothing else on the other side to subtract the 2.
You can. You could move the 13 over here and leave the 2 there. I like my numbers to stay positive, so that 2 I want
to
to
say positive, but I didn't know you could like switch the 12 and the 2.
Yeah, I can. Well, I'm not really switching. I'm gonna subtract that over to there, and add that over there.
And the same step, so that
So it's
there's
just
not.
a positive 2 instead of a negative.
Yes.
Correct.
So then it'll be a positive 2 over there, and then I'll just in my head, since we've been doing algebra for many years already, and this school year too, I just know that 13 minus 12, and I don't have to write all the steps. You can, please do if you think you need to. 13 minus 12 is 1x, so x is 2.
Okay, so x equals. Okay.
Okay. Be really careful on this next one. They're asking you to find the measure of VTU, not just find x. They're telling you the measure of angle 1.
To find x, you have to have.
Plug it back in. So they're telling you the measure of angle 2 and the measure of angle 1. What do we do with the measure of angle 1 and 2?
One
Put them equal to
One
each
equal.
other.
Put them equal to each other. So 7x minus 3 equals 1 minus 6x.
No.
No. I see. You're right. Just 6x. My bad. I'm going to do the same thing, Amy. I'm going to move that over there and that over there.
It's actually a lot easier than trying to do it like this. It's just x equals 3. Wait, so if you plug it back in, you just add them together then?
What are we going to plug it into? We're going to plug it into the measure of angle 2 or the measure of angle 1?
Doesn't matter.
Oh, yeah, okay.
And we're finding VTU, the whole thing, right?
We're just gonna multiply it by 2 because it's half.
Okay, so no matter where I plug it into, you're going to get the same answer, correct?
Correct.
And then I'm going to double my answer. So do you want to plug it into the 7x minus 3 or the 6x?
Oh.
That's what I want to do too. I want to plug it into the 6x. So 6 times 3
I did it wrong.
is going to be 18. That's only one side, though. That's only the measure of angle 1.
But since it's a bisector, it's gonna be the same on either side.
Okay, so both of them will be 18. That's correct. And so
We just circle 18 degrees as our answer.
is 18 degrees our answer?
No.
What is our answer?
18 plus 18.
18 plus 18, because if you notice, VTU is the whole thing,
Yeah, that's why we
and we only found half of it. So it's 18 times 2. What is 18 times 2?
36.
Yes.
I was
Alright.
doing it wrong.
So what we did was make sure you know what they're asking you. Sometimes they might be asking you for only half of it. This one was particular and was asking you for the whole thing. And since they were asking for the whole thing, we had to plug back into one of them, and one of them was just half of the whole, so we had to double it to get our answer. I want to check something real quick. You just learned today during this section perpendicular bisector theorem and its converse. You wrote it in there. The angle bisector theorem. We did a review of a construction. Are there any questions before we go on to the next one?